Hello, class. How y'all doing?
Hello.
Right. Anybody got
Doing
any?
good.
Anybody have any issue signing the roll?
Yes, sir.
Who is that?
Alexis.
Alexis. Alexis who?
Alexis Kim.
Okay, let me see something. What happened? What did it do?
Oh, I just said I just signed in.
Oh, but did you have any issues?
No, sir.
Oh, okay. All right. That's good. That's good. Yeah, because I think either toward the end of this week or next week we'll probably be doing our shows and no shows. So it's important that I have you recorded as being in class. Trying to look at my other clients real quick. About to get started. Almost at time. Okay, 10. Okay. Last Wednesday. All right. So we could get started. So let me share my screen. That's great. Share this. All right. So let's get started. And anybody with any questions? Any questions? All right. I gave you an assignment to do. Let's go back. Let's look at that first. But it's not due now, but let's look at it and let's see what all was entailed. All right. So I read it. These bonus assignments. So I gave you these assignments here. Basically, you click on this, and you would look at this. Well, here. All right, so I told you which one to do. I don't know if it's the first one or the second one, but I told you to type the assignment just as it is. All right. So you would start under whatever program, whatever, you start here and here. So, and whichever one. So we look at this, you see the code. All you have to do is, some people have the Mac. Like I say, you could use the X code or you could use the online GDB. But online GDB, like I say, it's not a full version of C++. So when you get to the next level and you start coding, some things might not be allowed. All right. So the thing is, if you have visual, once you download the visual and it's the community version, you would just open up visual, and I'll just go through it right now. Open up visual once it's loaded. Now, normally what happens the first time you load it, when you click, if I say create a new project, and this is, I think it's 2017, you would click create. And what happens is, on this side, it will show you all of the installed compilers. If you try to load everything, you may have Visual or Basic, you may have Python, you may have Java, you may have all those applications listed. But you would have to go here and make sure C++ is the one that's chosen, and then you would choose the Windows desktop. Okay. Once you choose Windows desktop, over in this section, you would say Windows Desktop Wizard. All right. You can give it a name. Like I could just give it a name. I could say sample program. Right. So this would be the project name. This is where it will, by default, will save my information. I could change this by simply, highlighting it through. If I knew I had a jump drive, whatever drive, I could put E colon, D colon, and whatever. Or if I had another drive on my hard drive, it was partitioned, I could put that letter drive and whatever path to it. But I'll just leave it as is, all right? Create the directory for the solution. So that means it's going to create an extra folder for the solution. It'll be in this folder, but then it'll create a folder with that project name, all right? And this is the name of my project. So I'll click OK here. Then it'll ask me a question. At this point, you'd want to choose empty project and leave it at that. Just simply empty project. Click OK. Once you do that, it's going to bring up the option to where you could create a header file, a data file, or the source file, which is the .cpp file. Well, I have to choose for it. So here, I can right click here, and here I do add. Okay, I want to add a new program, a new file. So I could do a header file, not a header, a .cpp file, which is the source, a .h file, which is a header file. Do class, but no, we're not doing classes in this class. But here I could go to utility and text and create a text file. All right. But we want to go back and we want to create a CPP file. All right. So this is the default. This is the default name, source.cpp. I could leave it at that or give it a new name. Now, if you notice here again, this is where it's going to create that file name. Remember, user, David, source, repos. All right. So this was the default folder, but then what? The name of my project is sample program. So it created that folder, And then within another folder, it's going to create all of my other supporting files, which is this file that I'm creating, source.cpp. I could change it if I want to, but I'm going to just leave it default. And I'll click add. Now I'll get a blank screen, and now I could type the program. So what you do is you have this screen open, and I'll just do the first one in that screen. So I'll do the / a simple C++ program. That's a comment, all right? If you see anything with / in front of it, is a comment. Then you have the pound, and you all say hashtag, but back in the day, pound include and IO stream. Now the IO stream is a library file, and we'll get into that later on. Library files are files that have certain code that give you functionality within the program. What happens is if I want to, an example, use data files to read or to write, I would have to load a header file called fstream. If I wanted to use string data types in my program, I would have to do pound include, and in those less than, greater than symbols, I would have to say string, and then I'm able to use the string option. So, and as you grow with C++, you'll know what libraries that you need to load, and we'll go over them as we go through the class. Right? So that's the header file, and then using namespace and the standard std, that loads standard libraries. So rather than having to load a particular library for the standard functions, and normally one of the standards is the input output, cout or cin. You put this in there, and then you have access to the library, the standard library for those standard features. All right. So now, once you do that, and if you notice, this is here a function. Every C++ program has a one main function. Okay. You got to remember that, a main function. So if we look at this part here, and I'll kind of move this over. A function has a function header and a body. All right. The function header consists of what data type is going to be returning, if any. If none is returned, it's void. The function header name and an argument list. And if you notice, there's no argument list. So the data type to be returned, the function name, and then the argument list. But then the body of the main function is enclosed in open curly braces and closed curly braces, and all your data, all your statements go within that body of the function. Right? So let's write that. So I'll say int main, all right, open, close, all right, no arguments. And then I'll do the open curly brace, and then I'll do the cout, if I can tell you. Cout. And then this says double quote programming is fun. Now, the thing is, if you notice in the compiler, when I hit a double quote, it automatically put the second double quote. Because when you start a double quote, you have to end it. If I do an open curly brace, it put a closed curly brace. Now, that's in this editor. Now, I could have done this same program in Notepad, but you wouldn't have gotten those features. You would have to put the second double quote. You would have to put the second closed curly brace and things of that nature. So it's not, you don't have to use the editor to actually create the program, but it kind of gives you a hint of where something is, where you have a mistake at, or, give you that option to have that other, let's say, okay, you got an open double quote, you should have a close. So it kind of helps you in that fashion. All right, return 0. Now the return zero saying what? If I have my function int main, I have to return an integer once I'm finished the program. All right. So if I run this, to run this program, all I would do the debug first. I want to build it, and then I'll do the compile. I'll compile it, and at the bottom, okay, I don't know if you can see it yet. This in the way. All right. So at the bottom it says one bill, one succeeded, zero failed. So that means there's no errors in the program. So a compiler will not completely compile a program if there's an error in it. All right. So now, once I do that, then I can go to debug and I can do start without debugging. All right. And what's going to happen is going to show me my results. And if you notice, you see all this here, this is just information after the program is ran. But if you notice this line here, it says programming is fun, exclamation point. Okay, so that's the output. Now, if you did this program, I'll look at it. If you misspelled a word, take off points. If you didn't put the exclamation point, I might take off points. So it's like you have to look at it and make sure it's the right output. Okay, it's almost like if you wrote a program where you print out a check, and that check has a person's name on it or some other information, and something is misspelled. If it's not correct, a bank can refuse to cash it. So you've done something, you ran it through the system, printed it out, but really what you've done is not, really correct, and you'd have to go back and fix it. So make sure your output is correct. Now, what I mean by that is, I'm gonna close this. And what you could have here, somebody could just say, programming is great fun, period. All right. And when I debug it this time, it's going to just say programming is great fun. Oh, well, excuse me. All right. All right. So it say programming is great fun, no errors, but what? Rather than an exclamation point, it has a period, which is not the output that should have been generated. All right. One other note, and then we'll get to the notes in the program. If you write your program, and I'll put the exclamation point back. Okay. You write your program, it executes one time, and then you say, well, I have an error. I need to go back and change something. And what you do is say, I have the exclamation point. I'll do something like, I'll do something like, I'll just put today here, like this. All right. So I made a change. All right. It shows an error, but I'm gonna just show you what happens when I try to just debug it. I'm gonna just debug it without compiling it. I'm gonna say start and watch what happens. It tells me there is an error. When I build it, do I want to continue? All right. And run the last successful build. Now, what this is saying is the program has previously ran correctly. Do I want to run that version? Now, what students do, they'll say yes, all right? And if I do yes, now notice what we want. We want right now, programming is fun today, right? I don't have no periods or nothing in it, but that's what we want outputted. And I'll say yes, I have errors, but I want to run the last successful build. Watch what happens. It's going to execute, but what? It's not the right output, because it ran based upon a previously successful execution. Okay, so you got to be mindful of that. And some students, what they'll do is they'll make a change, and they see they have and it's a logical error. They'll make and run the program, and it runs, but it's not the right output. Make a change, run it again, and they get that screen where it says the last output was successful. Do you want to run that one? And they say yes, run it, submit it, and then when I grade it, I take points off, and they say, well, Mr. Sylvester, my program ran. And I tell them it may have been the previous execution, but the one that you submitted did not work. Okay? So just be mindful of that. All right? Be mindful of that. So, like I say, on this one, all we would have to do is fix it with the double quotes, and that will solve the issue. Because what we want to, whatever we need to print in double quotes, now the colon, the semicolon is not a part of the output. It ends in that statement, and then it knows that this statement returns. All right. So now, another thing. Remember, I told you with the main. This is the data type. But if there's no data type to be returned, you could use void here. But if I use void here, I have to remove this return. Now, this program will work like this because what? I'm just, this is the body, all right? It says void, so that means there shouldn't be anything returning. And then now it should run just like a normal program, all right? So if I do debug, and see the program ran. But like I say, if I put a data type here, int or float or whatever, I have to return that data type back to it. And it just say return 0, showing that the program or that function have executed successfully. Any questions before we go get to the notes? I just want to show you how to go about writing the code, because sometimes it can be an issue if you misclicked on something or whatnot. All right. But you should be able to go back. I'm gonna post this lecture, so you'll be able to go back and look at this and write your code and compile it using Visual Studio. All right, and even online GDB. All right. Any questions?
Will this Zoom be recorded later on or no?
Right, that's what I'm saying. It's going to be recorded, so I'm going to post it. So you'll be able to go back here and use this as a guide to do your assignment.
Okay.
All right.
Professor, if we're using S code, would it be similar to what you just did on Microsoft Visual Studio?
Talking about Xcode?
Yes, sir.
Yes. The only thing, like I say, typing it in, same thing. The only difference would be compiling it and executing it. You'd have to do that in a different fashion. All right. But typing in the code, the statements and everything are all the exact same statements. All right.
Okay, perfect. Thank you.
Right. All right. Any other questions? But that's why I tell you to do a blank, empty project. Right. So that means it can run independent independently on any system. All right. All right. So if there's no questions, let's look at the notes. Now, the first notes is just basically introducing you to computer science and some of the jargon and whatnot, purpose of computer science and whatnot. All right. So, and I'll briefly go through the chapter, and like I say, I'll answer questions anytime you have questions or whatever. So just stop me or whatnot, and we'll stop and talk about it. So, it says, and I'll try to increase this a little bit more. All right. So I'd say, think about some different ways that people use computers. All right. And like I say, in today's society, almost and being that we in this COVID pandemic, almost everything, even churches now, using technology to have services and whatnot. So nowadays, almost every aspect of our lives is dealing with what? Some type of technology, right? Computers and technology. The schools, virtual technology. All right. So I think when it was either last year or year before, I went to a police station here in Baton Rouge. And I get in the police station expecting to speak to someone, face to face. And I walk in and I'm faced with a computer. So I have to to use the pad on the computer screen, all right, and with a touch screen, and then tell why I was there, whatever. Then wait, and then an officer's a video of an officer come on and question me about why am I there, whatever. So a lot of different aspects of computers. Computers are used in a lot of different ways now that we really never thought would be. And like I said, just the way our society has moved. All right. So it says people use them at work. All right. We use them at home with our banking. We use them, just like I said, now with our in education. So it's just many different ways, and we use our computer, let alone use our cell phones for what? Phone calls. All right. And like I said before, I would say I know when I was younger, if I was not home, I would miss a call if somebody would call me. I didn't have a cell phone on my side. You answer the phone as if you was home or not. And like I say, things have changed. All right. Computers can do such a wide variety of things because they can be programmed. So that's the big key. Because what? Our cell phones, just take those. They become more powerful because what? People can write apps to suit people's needs. So what? The more apps, the more variety of apps, the more convenient your phone becomes to you. All right, at home, away from home, or whatnot. All right, even on your business. Because some people may not use computers at their business. They may just use the cell phone. All right, so it's just a whole lot. Now, when we talk about programs, all right, this means that the computer must be the computers are not designed to do just one job, all right, but they can do many different jobs, all right, or any job that you need them to do, and that involves programming. Okay, and a program is just a set of instructions that a computer follows to perform a task. So when we look at this program in Visual Studio, all it prints out is what? I'll just take this off and put it like it was, all right? But this is a program, all right? A series of statements that perform a task. Now, what task is it? Whatever task you design it to do, but it's still a program, all right? So that's what a program is, simply stated. A set of instructions, a set of statements that the program follows step by step, to perform a task, right? Now, commonly used programs, we know that many times we use programs to banking programs, we use educational programs and various programs, all right? Programs are commonly referred to as software because we have the phone, but without the software or the programs being written, the phone is just another device that you have, and it can't do anything. Just like the computer. The computer without software is just a piece of equipment that you can just look at or whatever. Because the operating system that manages that piece of hardware is considered software. All right. So when you talk about Windows 10, that's software. Okay. Many different instructions that have been written so that it can operate your computer. All right. So let me move this over. All right. So in order for software to be written, we need there's a person that called a programmer, okay, or a software developer. All right. So you all are learning, hopefully, to one day become programmers or software developers, where you can I work for this company. They need to design a certain application for maybe another company, and then you all go ahead on and get a team together and design and create and test this software so that you can what? Sell it to someone or either what? Put it on the market. Okay. So that's what software is. Okay. And that's how that works. And there's a lot of testing that goes on with when you're dealing with creating applications. Because what? Number one, you want it to flow in the fashion that you want. Number two, you need it to give you the proper prompts and help menus when you're designing it. And then you want it to work on the different platforms that you run it, that you're working with, and you want it to be efficient, all right? So that it can be more, you can have it be more cost effective for the user, all right? So that's the software. So like I said, the software would be the program, but then we have the hardware. The hardware would be the physical device, okay? Like I say, a cell phone without software is just a device that just you can't use. A laptop, desktop, whatever, physical device, if there's no software on it, especially operating system, can't use it, all right? So the book tells us that hardware is a physical device that a computer is made of, and they are referred to as the computer's hardware. All right. Most computer systems are made of similar hardware devices. Okay. The term hardware refers to all of the physical devices because what? With your phone, your keyboard is pretty much on your screen. Your screen is your screen. Your mouse is your finger, the touch screen. Voice, same thing, input from the screen. All right. So with a cell phone, mostly everything, you may not have something that connects to it. You might use Bluetooth, or you might use Wi-Fi. All right. But you still can have devices because what? If you have an earpiece, that would be what? Hardware also, right? Using it with your cell phone, all right? With your computer, you might have what? A wireless printer or a printer that's connected hardwire. That would be another device or hardware device that's connected to the computer, all right? Which would be a component of that particular computer, all right? So, and the components would be any type device that's a part of the computer. So, let's say a typical computer system consists of the following major components, all right? The CPU. Now, CPU stands for Central Processing Unit, all right? So this is where all of your instructions are actually crunched and executed, okay? In the Central Processing Unit. Any instruction that's written has to go through the Central Processing Unit. Many times when you buy a computer, they may ask you the speed of your processor, all right? They want to know how many instructions can be executed in a given amount of time, right? So that's where your speed of your system comes from, all right? Main memory. Your main memory is your RAM memory. Now your RAM memory, RAM stands for Random Access Memory. Any computer that had, any device, all right, must have some RAM in it in order for it to work. Without that RAM, it cannot work. What happens is information is read into RAM and it's held and then it's executed. So you have to have that. It's almost like a person without a brain. And even though the brain processes the information, there's some part of the brain that has to take that information and store it, and then it processes. All right. So, and then with a computer, that main memory, which is your RAM, is where that information is held. I'll give you a good example of RAM memory, and basically RAM says random access memory. That allows us nowadays to multitask, all right? Where your system can do multiple processes at one time. Give an example. You might start your computer, all right? A process might be loaded in the RAM. You might go on the internet. That process is in RAM. You might open up an application on your computer. That process is in RAM. But now what? I have my operating system loaded. I have whatever process I had loaded, and I have the internet loaded. And I can switch between each one of those randomly to do what I need to do. I don't have to exit out my computer, start it back up, and then just go into that one application. Use that one, cut the computer off, load the next one, and then use that one. Like I say, random access memory allows me to have multiple processes loaded, and I can move from one to the other and use them as needed, all right, without having to reload them, all right? So, and like I say, look at this down here. I won't say down here. Let me open up this. All right, this is just an example. So I have Gmail loaded. I have my website loaded. I have YouTube loaded, but they're all are resident in RAM. When I click on it, it don't have to go and reload something. It's already there and available for me to use. So that's what RAM memory allows me to do. It allows me to have random access to those applications that I've opened. Now I can't close them. All right, I can always close them and then reopen them, but I can keep them open where I don't have to have it reopen each time. Now, and then RAM memory is volatile. What that means is if I open up the internet, open up application, open up something else, everything is available to me as long as my computer is turned on. When I turn my computer off, I lose everything, all right? It doesn't save say, oh, I have this open, I have that open, I can go to it. Even though nowadays you have something to where the computer can remember what you had previously open, but that's dealing with some files saved on your computer. But RAM memory is lost. When you turn the computer back on and you start going through the different opening applications, you putting in more different applications in your in RAM memory. All right, so it creates a new RAM list. Now, secondary storage devices. These devices would be devices such as a hard drive, a USB drive, CD-ROM, CD drive. All these devices are secondary storage. Now, with secondary storage, if I save something to a secondary storage device, if I turn the computer off, it does not delete or remove that file from that device. All right, because if I'm working in my computer and I have a USB drive in my computer and I save a file to it and I turn my computer off, I still can go to that computer or another computer or either that computer, put the jump drive in or the flash drive in, and I can open up my file. All right. So that's secondary memory or storage or storage. All right. Now, in operating a computer, you have devices that's called input devices and devices that are called output devices. An input device would be any device that aids you in putting information into the computer. An output device would be any device that allows you or aids you in outputting any type of information from the computer. So let's look at this chart here to see what are some typical components that are used for that's on the computer and how they are categorized. So if we look at it here, our CPU, all right, I don't know if anybody have opened up a computer before, but if you've seen this chip here, that's your CPU, all right? And like I said, this is how it may look. It could look a little different, but normally this is how it would look. Your RAM memory. Your RAM memory typically would look something like this, all right? On a laptop, it might look maybe a little smaller and thicker. It depends, all right? But typically, this is how your RAM memory would look. It's like SIM chips, all right? Then your secondary storage here would be what? Your a hard drive, could be a CD drive, could be a jump drive, but they just put the hard drive, all right? Then we have devices that allow us to feed in information into the computer. What? The camera feeds in the video. The joystick is similar to a mouse. You can say a joystick is a mouse because the joystick allows you to what? Maneuver a cursor. When I'm playing a basketball game, when I'm using a video game that has a race car in it, and I'm using a joystick to make it go left, right, or jump or whatever. The object on the game is your cursor. Okay, the joystick would be the mouse that controls what? That cursor. So you could kind of look at it like that. We look at it as an object that we controlling. And well, when the mouse itself is a what? An object we controlling on the screen. So a joystick is considered somewhat like a mouse, all right? Input. Keyboard. You're inputting what? Letters, numbers, control commands, etc. All right. A scanner. It scans information and feeds it what? Into the computer. All right. And this would be more or less that what it is, those pads where you can work, you can actually highlight something or tap something on the screen, but it inputs it and puts it on the screen. So it allows it an instructor or anyone, a presenter, to colorize something on the screen, circle something or whatever. So that's what they like a pad, like a notepad. All right. Now we have output devices, but on this side, I would say a monitor also can be a what? An input device, correct? Because some monitors are what? Touch screen, right? So a monitor, I would say, can also be what? An input device or an output device. Because even on your phone screen is your monitor, because what? Whatever you see is displayed on that cell phone screen, and what? You can use your fingers to tap on the screen to what? To input information into the phone, or either a touch screen or laptop. All right. So I said the monitor could be an input device or an output device. Now, and then we have the printer, and we all know that printers normally prints out our reports or whatever it is we want to what, or photos or whatever that we want to print out to have a hard copy of. And then we have what? Our speakers. Our speakers would be what? Output, because what? We able to what? Listen to music, listen to a ding or a dong, depending on what happens on a system or whatnot. And on this side, another input device could be a microphone, because a microphone allows data to what? Go into the system so that it can be processed. And then what? The speakers output. All right. So these just are some devices. Give you an idea of what input is, what input devices are, what output devices are, and like I say, your CPU and your main memory and your secondary memory. All right. So pretty much went over this, the CPU, what is the CPU? You can read through this to get a more clearer idea of what it does, but basically we went over this, what the CPU is and how it runs, all right? This just shows you back in the day, this would be considered a computer, all right? And the amazing thing about it is, this system here, and many of them like it, did not have enough power as one of the like smartwatches or whatever have today. You know, it's just that's how they just the day of the times. You know, computers became more and more what? Faster, more and more reliable and whatever based on over the times, things, and it's smaller. So they started out discovering computers and then eventually started designing them to be more and more conducive for a single user and also more readily with data, faster and whatnot. So that's just the design of it, and you pretty much have to know that system. Almost looking at it, and you see it like an operator from the back in the day with the telephones with a switchboard. You're plugging in circuits to different places or whatever. Nowadays, your computers are smart. You can say they're smart computers because a lot of things that they had to do, we don't have to do in this day and age. Even in coding, we don't have to do. So look, it's showing you this is the microprocessor that's equivalent to what this stuff was doing back in the day. So it's like, just times have changed. All right, times have changed. Main memory, we talked about main memory. Your main memory is your RAM, and RAM stands for random access memory. And we talked about it being volatile. It's only available when your computer is on. Once your computer is off, you're starting afresh, starting anew. All right. So you got to be available. Now, this is your your memory chips. All right. This is your RAM memory. All right. That's your main memory, your RAM memory. It could look like this. It could look a little different. But basically, when you see something in this fashion, this is your RAM memory. All right. Secondary. We talked about secondary. Now, how many people know what a floppy disk is? Anybody? Anybody? You know what a floppy disk is?
Yeah, it was when I was a kid.
I do. We used to use them. We used to use them years ago.
Yeah.
Yeah,
right.
I definitely know what they are. We used to
Now
use
let
them
me ask you,
years ago.
what was the size? What was the size of them?
They were about 3-inch square. I would say.
It was like a little square.
It was
Yeah, it
like-
was like a little square.
A couple inches.
Now that was true too. They had the three and they had the three and a half. But they had the 5 1/4 too. You ever saw the 5 1/4? But they had the 5 1/4 too. You ever saw the 5 1/4? They were flimsy. They was like you could bend them in half. Right. So you had to be very, very delicate with those, right? And then they had some that was a little bit larger that worked with the mainframe.
Yeah.
Right. So they had floppy disks. Right. But as I say, with computer science, what we do, we tend to try to get smaller and smaller and smaller. Because on a flash drive now, you can put almost as much, or you can put more data on a flash drive than you could have put on a hard drive back in the day when they had a floppy disk. Because back in the day, the hard drives, I think you probably had maybe 32, I don't think it was gigabyte. Hard drives they wasn't that large. Like you might have had a 500 megabyte hard drive, but now you got 64 gigabyte jump drive, and then you got the little memory chips now, or like say a mini SD card that goes up way higher than that. So you can put more information on a jump drive than you can back in the day on the hard drive. But that's the way technology works. It moves until, like I say, it becomes smaller and smaller and smaller, more versatile. Because now even we use technology, but then we have other agencies like the FBI, CIA, and whatever. They use technology too. So when they use technology, they have to be more kind of incognito with their stuff. So they design stuff to be more compact. And then we in turn fall into that same thing, saying, well, I want something that's more more easy to handle, put in my pocket. I don't, nobody see it, and I'm going about my business. So we adapt to what they do a lot. You know, a lot of stuff that we have was designed by the government first. You know, that's just the way it works. Right? The optical disc, which is the CD-ROMs, the DVD, all those are your secondary storages. All right. We talked about input devices. We talked about output devices. And like I said, all your input devices just allow data to be fed into the computer. Output devices allow data to be outputted. All right. So now you can go over your checkpoints to just make sure you're on task. All right. Make sure you go over your checkpoint question just to kind of review. It'll help you with your exams. All right. Now, how computer store data. All right. Now we've saw the move. What it was the Matrix. A lot of times, I think it was the Matrix when it first the first method. When you saw the Matrix, you had what, the zeros and ones on the screen or whatever. So those zeros and ones represented what, data that what was in in the computer, right? Because the only thing a computer understand is what?
Zeros and ones.
Zeros and ones. A picture, the computer understands what?
Zeros and ones in the data flow.
Music, the computer understands what? Zeros and ones. So like I say, we see certain things, but the computer understands it as just zeros and ones. So what happens is we have information in a certain format, even a document, our document, or even our program that we write. Our program we type in the program what int main, cout whatever. We type that code, but the compiler takes it, checks for errors, then it takes it and converts it to an object file, which in turn it takes it and creates it into machine language so that the computer can understand what it is. So just because we see it as one thing, the computer only sees what? Zeros and ones. Now, in doing that, this is called what? Zeros and ones. When you're dealing with just zeros and ones, that's called what numbers? What type numbers?
Binary.
The binary digits, ones and zeros. The one signify on, in a sense, the zero signifies off. All right. So when we go down further, we'll learn how to understand what's happening. So we look at this, and this says when a piece of data is stored in a byte. Now a byte, 1 byte is equal to how many bits, class? If anybody know. All right.
128, sir.
One byte.
1 by 1.
Is equal to how many bits?
8 bits, I think.
8
I'm
bits.
gonna guess 64.
1 byte. All right, a byte is a character, right? So say take back BRCC. BRCC is how many bytes represented in just BRCC? Bytes.
4.
4 bytes. Every character that you can type in on the keyboard is a byte. Okay. When you type in a document, every character, like here, CAN space HOLD, that's 8 bytes. 1, 2, 3. A space is a character. Every character is a byte, has to be represented in the computer. All right. So now each character is 1 byte. Each byte is consisted of 8 bits. So BRCC is how many bytes?
I think it's just 1.
BRCC.
4 bytes.
4 bytes. BRCC.
4 bytes.
Each character.
32.
BRCC.
32.
Just 4.
If it's 4,
Just 4. A byte is a character. A byte is a character. All right.
So 4
what's your
bytes.
name? What's your name? All right. What's your name? What's your name?
Mine is Kobe.
All right, how many letters in your name? In Kobe.
Four.
All right, how many bites is Kobe?
4.
All right. Now, now if I say how many bits is in Kobe, what would you tell me?
If I say how many bits is in Kobe, what would you tell me?
Then it would be 32.
32? In Kobe?
32?
4.
Yeah, 8 times 4,
You
right.
said bits, correct? Like you
Right,
said,
you're
each
right,
bit
yeah.
is each bit is 8, and if I have 4, that's 32.
Right, correct. So that would be
Okay.
8,
Right,
8,
okay.
8, 8. So you understand? So the bits is different.
Okay.
Right. Right. So now look at let me show you the ASCII table.
Let me show you.
And we'll kind of understand a little bit of it. Let's see here. If I say let's see here. I'll choose this one. All right. So let's look at this. Let's look at this table here. All right. Now, can I do something? It's only gonna show octal. It ain't gonna show the binary. It won't show binary. All right, but yeah, well, it'll show the character. Where is the letter A? So okay, here we go. All right, here we go. The decimal value for the letter A is what? Looking at this. The decimal value is what?
65.
65. Notice every character, if you look here, all these are characters. The letters, if you go here, all these characters, I need to scroll over. You got the division symbol, all these mathematical symbols. Then they got all these other non-printable symbols. So every character, and then they got the lowercase letters. So every character has a binary value. So we say the letter A has what is what 64, right?
65.
65. All right, 65. Now, what happens is, and let me go back to here. All right, it got some. I'm just dealing with 77 here, but let's look here. All right, so here, notice this shows on, off, 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 on, off. Now you say, well, what does that mean? The letter A is 1 byte, correct? 1 byte. Everybody got that. But it is 8 what? Bits.
Yes.
Now, let me see if I can write on this screen. Let me go
to the binary.
right. But what I want to see if I can, I want to write on this. Let's see. It's going to, hopefully it don't take me. Well, I'll do it down here. All right. So what happens is, you have, and hopefully you'll understand. I'll do this like this. I can't draw too good with this pen. What happens is, you take the binary placement table, and I'm trying my best, class. All right. 2 to the 0 power, all right, is 1. All right. 2 to the first power is 2. Hopefully y'all can understand. 2 to the second power is 4. 2 to the third power is 8. So you see what's happening? I'm creating a table, kind of like with the tens table. Like when you're doing multiples of 10, 10 to the 0, the ones, 10 squared, 10 to the 1, 10, 10 squared, hundreds, 10 cubes, 1,000. And that's how we get our numbers in our decimal place numbers, our decimal value. 2 to the 4th. Man, that's 16. That's 2 to the 4th. 2 to the 5th. I can't write. It's 32. And 2 to the 6th is 64. All right. Now, so what happens is, that's 1, 2, 3, 4, 5, 6, 7. All right. So then I would have, for 8 bits, I would have to have that other bit here. That would be 2 to the 7. All right. All right. We know that 2 to the 7. And that would be that is 4, 8, 128. I can write. All right. Now that's 128. So what happens is, now we know that what? The letter A is 65, correct? That's the decimal value. So what we have to do is, using this table, try to find out how we can represent 65 using this table. Now, and I have some instructions on what we're going to use, because we're going to have some exercises on how to convert decimal to binary, binary to decimal, etc. But the letter A is 65, right? So what you do in this placement chart, you find the value that's the highest value that is that's closest to 65, but not above it. And that would be what? 64, right? So what I would do, I'll put a 1 here. All right. Now, 65 minus 64 would give me what? 1 left over. So now 1 is less than 32. I'll put a 0 here. It's less than 16. I'll put a 0 here. It's less than 8. I'll put a 0 here. It's less than 4. I'll put a 0 here. My fault. I can't do this. Put a 0. Less than 2. I'll put a 0 here. But 1 is equal to 1. So what? 64 plus 1 is what? 65. And what? If I was going to represent it in 8 bits, now the letter A is represented as what? 0, 1, 0, 0, 0, 0, 0, 1. Everybody see that?
Yes, sir.
So the letter A is 1 byte, which is what? The letter A, but represented in 8 bits, it would be what? 0, 1, 0, 0, 0, 0, 0, 1. Now I know you might be confused, but we're gonna look at it a little bit more when I'll go to this other part. But everybody kind of understand what. Everybody can still see my my note screen, huh? Or you can only see the whiteboard.
No, we can only see this.
We can see the notes.
Okay, all right. So
We can see the notes.
all right. So, but you understand how I got this.
But you understand how I got this.
Yes,
But
sir.
we'll look at it a little further. So now,
Look at it a little further. So
but
now,
look at this one. You got
look at this one.
1 is on, so you got a 1 here.
1 is on.
2 is
Got 1
off.
here. 2 is off.
4 is on. So that's what? 4
is
plus
on.
1, that's
So
5.
4 plus 1, that's 5.
Okay, 8 is on.
8.
So 8 and 5 is what?
So 8 and
13.
5 is what? 13.
Okay. 6, well, is that
6,
off?
is that off?
Wait, it was 0, 1, 2, 3. This is 0, 1, 2, 3.
This is 0, 1, 2, 3.
4 and 5 is off.
4 and 5 is off.
6 is on, and 6 is what?
It's on, and 6 is what?
64. So 64 and 13
So 64 and 13
gives you that what?
gives you that
77.
what? 77.
So you see what happened? This particular
What happened?
bit representation
Bit
is
representation
77.
is 77.
Okay? And this one was 64.
And
So
this
let's
one
look at
was
our ASCII
64.
table.
So
What's
let's look
up?
at our ASCII table. What's
77 is what?
77 is what? M.
You see what I'm saying? So that's the ASCII. This is the decimal value, all right? But this is the, well, we looked at the binary value. We calculated the decimal value, and then we looked at the chart, and this is our actually byte or char value, all right? Now, let me switch back to that this screen. Well, I want to stop sharing. I don't want to stop. Can everybody see my screen? My notes?
Yes, sir.
Okay, all right.
I can't see it for some reason.
The notes, you can't see the notes?
I can't see the notes either.
Okay, let me go back. I'm gonna do a stop.
Okay, let me go back. I'm going to do a stop.
And then I'm gonna start sharing again. What about now?
Yes, I can
What
see
about
it.
I
now?
can see it now.
Okay,
There we go.
all
There
right.
we go.
Okay, so now
Okay.
let's go to my SYL site. I'll go here and I'll go to 192. And if we notice down here, I have a video for conversion. Well, they're not videos, but we're going to look at these conversion instructions. So here we are. We have instructions on how to convert a decimal to a binary value, all right? So what happens is they got step-by-step instructions. So they were given the number 49, okay? What is the binary value of 49? So what it says, the first step is to have your placement table for the binary chart. This is your decimal value, but this is the binary placement chart. This was what I was trying to draw a few minutes ago. So what? A placement table, you start with what? The 0 power, first power, second, on and on and on and on. But we dealing with binary, so it's what? 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth. You understand? So we have that placement table. So anything to the 0 power is 1. And anything to its into the first power is that number. Then 2 squared is 4. 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. So you see what we're doing? We actually increasing the number. So now it tells us if we want to find the value, the binary value of the number 49, what you do is find the highest value that is less than or equal to that number. So the highest value is 32. It's less than or equal to, but you can't beat you 64 because you went above. So we'll put a 1 in that column. So that's 32. So we subtract 32 from 49, we get 17. So to find the number, the highest value that's less than or equal to, that's 16. So we put a 1 in that column, and then what? We subtract 16 from 17, and we have a remainder of 1. So you have to put the zeros in these columns because what? You can't say 49 in decimal is equal to 111 in binary. You get the wrong value when you try to use it. So you have to put these zeros here and then the 1 and subtract 1, you got 0. So if you look with the answer, 49 in base 10, right, is equal to 110001 in base 2. All right? So that's one. And like I say, there's other ways of doing binary conversions, but this is the one I have listed here. You can Google it on in YouTube, and there are some other ways, but I have these here as instructions so that you can follow. Because you're gonna have an assignment where you're gonna have to convert binary to decimal, and decimal to binary. Now, let me ask you this before we go on. If this is the way you convert a binary number, a decimal number to binary, then what? Just by looking at this, all I have to do is what? 32 times 1, 16 times 1, 1 times 1, and I get what? 49. So to convert a binary number back to decimal, I'll just use my placement table, place my number under that table, and wherever there's a 1, I'll just add those columns, and I'll get my results. Now, the instructions say start from the right going to the left, because what? If I try to write 110001 and I got a space here, then I might be confused. I might add a 0 or whatever. Or if it's a very large number, I can start writing a 16-digit number, and I got to go back and start writing it over. But if I start from the right, coming to the left, then I just fill everything in. All right. Whereas, like, say the 1, go here, the 0, go here, 0, go here, 0, go here, 1 here, and the 1, right? Starting from the right going to the left. So it tells us, all right, to convert a binary to decimal, all right? All you do is simply take, starting from the right, plug in the numbers under the binary placement table, all right? And then add, wherever there's a 1, you add those numbers together. 32 plus 16 plus 1, and that gives you the 49. All right, so binary to decimal, decimal to binary, okay? And that's how numbers are converted. We do it. The computer does it too, because the computer has to convert everything over to binary. All right, let's go back to the notes. All right, so that's what this is all about. Numbers are stored, data is stored in the computer so that the computer can read as zeros and ones, all right? So it says storing numbers, all right? A bit, remember, can be stored in a very limited way, all right? To represent numbers, okay? Depending on whether the bit is turned on or off, and we talked about that. Now, this is basically the same thing we talked about from the website we just left. But if you look, 2 to the 0, all right, 2 to the 1 is 0. So here we can look at this and say what? 1, well, here would be what? 1, well, there's 128 plus, oh man, that's 128 plus 16 plus 8 plus 4 plus 1, right? So that would give you that numeric value, all right? That decimal value. Looking at this one, well, really is the same thing, 128, because 2 to the 7 is 128. Okay, this is 0, this is 0. You got 16 plus 8 plus 4 plus 1, right? So it's the same difference. All they did was use the what? The exponents, of the placement table, with the placement table, and this was the actual values at those particular positions. All right. So It says to determine the value of a binary number, you simply add up the positions of position values of all the ones. Same thing in the other instruction. For example, the binary number 1001101, which was this number, the position values of the ones is 1, 4, 8, 16, and 128. This is shown in this figure up here. The sum of all of these positive values, the position values, is 157. So the value of the binary number 1001101 is 157. Now, I want to let you know, though, class, binary digits can go what? Beyond this, so what? We can have 2 to the 8, 2 to the 9, 2 to the 10, 2 to the 11, 2 to the 12, going on and on and on. And you just have to plug the numbers in to get that binary digit, all right? So all it's showing you, just the breakdown, what numbers it had to add. 128, 16, 8, 4, and 1. Disregarding the 32, and the 60, well, what it was, 64, 32, and the 2. All right? All right, this is the representation if you had bits on and off, on, off, on, off, on. All right? So basically, it's just kind of going through showing you what it is. Now look at this one. You got 16 bits here, right? And all of them are turned on, correct? If all of them are turned on, that means you add what? 2 to the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way to 2 to the 15. But you add what? Each one of them up, right? And you add them all up, and you come up with 65,535. All right. So that's just showing you what happens. Now, characters. If you notice when we looked at the letter A decimal value was what? 65, correct? We're going to kind of learn in computer science that really the character values are stored as numbers. But we see them as what? Letters, because of what? The data type we put on it. And I could write the program and show you. If I had the letter A, all right, let's go through this, then I'll show you that, and then we'll go, because it's almost that time. It says any piece of data that's stored in the computer memory must be stored as a binary number, all right? This includes characters. So that statement right there tells you anything that's stored has to be stored in numbers. So what I'm gonna do, I'm gonna go back here and show you, all right, right quick. So what I'll do here, I'll do something like this. Char letter equals A, all right, the letter A, all right. Then I'll say int and I'll say let equal letter. All right. So what I'm doing now, I have a char value of the letter A, but then I'm taking that char value and storing it in an integer. And now I'm going to do cout, and what I'll do, and then we gonna go T. All right, and what I'll do, I'll put let. All right, so now when I run this, look what I got. Look what it outputted. See what it outputted? 65. Because what? The letter A is really stored in the computer in what? In decimal form. You understand? Remember that statement I just read you? It says any piece of data that is stored in the computer's memory in binary must be stored as a binary number. So even though I stored in the letter A, it didn't store in what? An A, it stored in what? 010000001. Right? So when I said take 001000001 and output it as an integer, it's going to output what? 65. All right? So that's what I was trying to get you to understand. All right? It's stored in, I read it in here as a character, but it doesn't store as a character. It stores it as a binary, not binary. And then when I output it as an integer or the decimal, it takes it and turns it to that 65. All right? Because what? What is letter? Let equal letter. What's letter? Letter equal to A. What's A? A is 1000101. Right. So that's what I wanted to kind of get you to understand. So what I want you to do, class, I got an assignment with binary. All right. Use your notes, use the Google, use the website, and I need to post it if I can get to it. Yeah. All right. Where is it? All right, I'm gonna go to Canvas again. All right. And what I want you to do is that binary to decimal and decimal to binary. Let's see here. I think I got it on the quizzes or assignments. Okay. All right. If I can find it. Not having it on the quiz. All right, so look here. Binary to decimal. All right. So here it tells us input your answers omitting leading zeros. All right. So what? Remember, if you have something if you're doing something like say 8 bytes and it says 0001111, I don't want the leading zeros. I want starting at the significant digit of 1 going to the end. Everybody got that, or it will be marked wrong. Okay. So no leading zeros. All right. So it tells you to input your answers omitting leading zeros. Okay. Also, for any invalid numbers, enter the word invalid for your answer. So let's look at, let me do an edit. I could have did a preview. I need to change this too. I'll change it after. And I'll give a date. I need to go here. All right. So if we look at this, you have a number 0101011. I want you to take that binary number and convert it to decimal. Right? We went over that process a little while ago. If you got issues, look at those. I'm going to post this. It might take 15, 20 minutes, but then I got my other class. But I'm going to try to post it before 5 o'clock. You'll have it. You can look at it and do that while it's fresh on your mind. Then I got what? Convert 142 to binary. So you got a number 142. Remember, do your placement table. The highest value less than or equal to that number, put a 1, subtract. We'll do it again. Put a 1, subtract. And like I said, all the places where you had nothing, put zeros and then put your number. And then omit leading zeros, like I told you. So a little quiz of converting binary to decimal and decimal to binary. Okay? And on next class period, we'll look at converting binary to octal, octal to decimal, and then hex to binary and hexadecimal to integer and all that. So we'll look at that on next class period. All right. Any questions? Let me put the details in for this thing here. All right. So I'm gonna give you 2 attempts. All right. We got 30 minutes, so you got a time limit. You ain't got time to just be all day on the thing. All right. I'll take this off. All right. And what today is, I'll make it due They're not the 29th. All right, so today is the 19th. I'll make you do in the class well, if anybody got issues, they'll be able to talk to me in class the next class period, but they're gonna be due the night of that next class period. All right. But don't wait. It's best to do it in enough time where you can get it done. But if you have issues, you can always ask me. Well, I got 3 o'clock. Let me change that time. Well, 1 o'clock. Well, yeah, I'll set it right before class time, which is 10 o'clock a.m. Yeah. So like I say, try to get it done before then, before next class period. 10 o'clock a.m.
Mr. Sylvester.
Yeah.
This isn't about that quiz, but about the assignment 1, program 1.
All right.
Whenever we're submitting the assessment, and we go to choose file, do you want us to just submit the source code .cpp?
Wait, the assessment?
No, the assignment for
the assignment. Yeah, just the .cpp file, right.
Okay.
Oh, yeah, that's something I could have. Yeah, what you need to do, like say, remember I showed you the in a visual, in the path of where it was saved?
Yeah, because it's saved in a big folder of, a bunch of different files.
Right. So what you do, you go to it. Let me see if I can go to, what is that assignment? I'm going to show you right quick. Let me go. Let me see. It's saved. Okay, I'm going to go back to modules. And let's see if I can do it. So if I go to, right here, if I click here, and I want to edit. Oh, yeah, okay, when I do submit, so now I do choose a file, and I know mine is somewhere in, where is that? This computer. See, where is it? Users, name it. Where's repo? Oh, source, repo. What did I call it? Sample program. And see, source.cpp.
Okay, yeah, that's what I thought it was. I was just trying to make sure.
Right. And then I'll just do open because that's the file I want to upload. See, when I click open,
yes, sir.
Okay, and it's going to take that file, and then I'll do submit, and it's going to submit the file. Okay, so you got to know the path, though. You got to know where it is, right? Right. So just the .cpp file. That's it. That's all. Because like I say, that visual got a lot of other supporting documents like the SLN. I don't need that. That's with visual, right?
Yes, sir.
All right.
Yeah, I just got it submitted, so it should be good.
All right. Any other questions?
What are the assignments posted on the SIL9 website?
No, no. That's just supporting documentation.
So all like homeworks and quizzes will be done through Canvas?
Right, correct. Now, like I say, the only time we'll do something from the SYL site if I'll say, okay, this assignment, or what I'll do, I'll link it to my Canvas. You got what I'm saying? But yeah, it won't, all that's out there, you're free to look at it, you're free to work on it or whatever. You got what I'm saying? Yeah. It's just to help you. Right? Any other questions?
When you can go first.
Installing Visual Studio, there's a bunch of other extra features and options. Are those necessary?
No, just do the community version, and that's it. Yeah, you don't, just in the C++, that's all you need.
Okay, thank you.
Yeah, that's it. Anybody else?
I have a question. Did you get my email about disabilities or no? Because I'm not sure.
What's your name? Last name?
Prado, Prado. I sent you one. from right there.
I doubt it. Normally I would remember. I don't remember that name, but just resubmit it to me.
Okay. If you don't, can you send me email tomorrow? If you don't get it today?
All right. Prado Pio. Okay. Yeah, because I think I got one, but it was from another class. I remember that one, but I don't know about this one. Yeah. And I might have gotten it and not remembered it, but I could look. But resend it. It won't hurt to resend it.
Okay.
All right.
Thank you.
All right. Anybody else?
Yes. What about your exams? I see that it says the testing center is closed on your assignment details. What about those?
What about them, no?
So are we doing it through these Canvas?
Right. What's going to happen is Proctorio. You're going to use. You're going to have to, because I think I put something in on either announcements or let me get out of this. In announcements or the bonus about Proctorio. Let's see something. Using Proctorio, let's see. No, it's probably in bonus. Go to modules. Let's see here. I think I have Proctorio somewhere in there. Yeah, see here? Proctorio exams in Canvas. See here?
Yes.
Yeah, so what's going to happen is you're going to have to, if you don't load it, when you go to take the test, you're going to get an orange screen with a diamond and a question mark in it. Well, like not diamond, a rectangle and a question mark in it. And it's going to ask you to load the extension. You can go to the page and then you got to click on it and then load the extension in Chrome. You got to be in Chrome, and then it's going to allow you to take the test. Because if you ever take a test and it says, please enter the password, something is wrong. Because the password is controlled by Proctorio. You know, you don't have to, you shouldn't have to enter a password. Yes.
Is it required to have a webcam to use?
Yeah, because see the Proctorio, and I think, and I say yes, because I don't think my tests I require you to use the camera. I'm not sure. I know I set it up, but the final, definitely you will have to have a webcam because it's gonna ask you for your ID and all this and that, whatever, to make sure you're the one taking the test and all that. So you're gonna have to have it. Definitely for the final. I think for the test, I'm not too sure. But definitely for the final. So you're gonna have to have a webcam sooner or later. Yeah, you're gonna have to have one.
Gotcha. Yeah. I ordered one, but it's just not in yet.
Okay. Well, normally I take tests after each chapter. After we go through each chapter, you got your questions, you review questions at the end of the chapters or whatever, and then like I say, then I post the test. Now, just like I gave the assignment. The assignment went from today till what? Class time, right? With the test, normally I'll say, okay, like say if I gave a test today, I'll say, okay, the test is open from today until Monday. You understand? So you have like a week to take the test. So anytime between that week, if it's midnight, whatever, or 5 o'clock, whatever, or 2 o'clock in the daytime, anytime between that start date and that end date, you could take the test. Any other questions? And you do have 2 opportunities to take your test.
I have one question. Do we have to have a video on? We have the have a test on our camera.
Right, that's what the guy just asked. Yeah, and definitely for the finals. For the other test, I'm not too sure, but definitely for the finals. So sooner or later, you're gonna have to have that camera, that webcam.
Oh, okay.
Yeah,
mine's broken. Mine doesn't work anymore.
Wow, yeah. You don't have a laptop? Laptop.
I'm using a laptop. It doesn't work anymore.
Oh, okay. You find your USB camera and connect to it. Yes. Who have a question?
Yeah. Was there a quiz or a assignment due today? I came in a little late, So I was kind
I didn't give any quizzes yet, but I assigned a quiz that's gonna be due for before next class period.
Okay.
Yeah. Yes,
All
I
right, got
did.
it.
Yeah, I did assign this binary conversion quiz. You're converting binary to decimal and decimal of a binary.
Cool.
Yeah. All right. Any other questions? Yeah. Any questions? All right. So if there's no question, review the notes. I'll try to put. I'm gonna post the notes, and I'll put a link where it. I'm gonna put that link. I'm gonna put that link in. Yeah, I'm gonna put that link in here. All right. I'm gonna add that right here. Wait, let's see. No, not there. Man, at the end, it's gonna be the Zoom lectures. All right, it'd be like the YouTube playlist. This will be the first one. The other one was just general information. I might put that one, but that was just the general information. But I'll add this one, in there, and you'll be able to see the link. You'll be able to click on it and view it and do whatever. All right. But I think you still can go to Zoom and get to it there. But I'll just put a link here, make it more convenient. All right.
I have one more quick question.
Yeah.
I can still upload program 1, assignment 1 through like compiling with online GDB.
Right. But like I said, once you get to that next level, it'll be because some of the feature, like I say, in online GDB, you don't have to declare a variable to be equal to 0 in order to use it in the program. It's understood. But in those higher levels, they're gonna give you an error. They're gonna say, "Oh, this is undefined," and some other little things too. It'll give you little issues because it's a little watered down, but it works. You know what I'm saying? It works just the same. Yeah.
All right. Thank you.
All right. Any other questions? All right. Okay, if there's no questions, like I said, I'll see y'all on next Tuesday. And like I said, make sure you sign the roll, class. So make sure you sign the roll. Some people may have gotten off and didn't sign it, but make sure you sign it because we probably gonna be starting to do our shows and no shows. All right. So I'll see y'all on next class period. Have a good one.
You too, sir.
All right. Bye-bye.
Thank you.
You're welcome.